Hello, my name's Ian Howells. I'm the CMO of Store Simple, and lesson one in this series is Think Like Google. Before we go into what we really mean by that, it's worth looking at how content is growing at a rate of kind of 50 to 60% per year, typically in large enterprises. And what drives the content growth is typically Microsoft Office, SharePoint, and email around Exchange. So if you look at a typical PowerPoint presentation like this one, it may be, let's make the numbers simple, 5 megabytes. An author may create that 5 megabyte PowerPoint presentation, then they may just change one word on the title, and they create another version, but that version typically will be another 5 megabytes. Then they're going to send it maybe through email to multiple people to review, and then it's going to be stored, and the approved version can be distributed, and it maybe has public access. Then maybe on a weekly basis you're going to back up the presentations, then you're going to archive them. So already one simple 5 megabyte PowerPoint presentation may easily be stored 20 times, and that's going to cause a storage overhead of about 100 megabytes. So it's much more than that 5 megabytes. And if you look at what we're really doing here, we're creating version after version, and most people care about the latest version. And if you look at the expansion of this, people want to store more than Office documents in SharePoint because they want to use SharePoint and they like using SharePoint. They want to store videos there, they want to store sound there, and maybe drawings. And a great example is one of our customers, which is a construction company. And the construction company revolves around CAD drawings and videoing on site any issues they've got with a building. And the users wanted to use SharePoint for this, but they were banned from putting CAD drawings and videos into SharePoint because it got too big too quickly. So when you look at this and how you can approach this problem, one way is to look at it this way: is content's getting out of control, growing 50 to 60% annually. And one good analogy to look at in this sense is Google. And we talk about content communism doesn't work. Google doesn't treat all pages the same. If it did when you did a search, the page you wanted may come on results page 1 or page 20, which would be utterly useless. And they have a concept of page rank. So the pages you want to see get on the first page. And they've learned that that algorithm is very powerful, but you need to be able to run it automatically without human beings categorizing the pages. And we need to take a similar approach for cloud storage. And the analogy here is something called block rank. And the core thing we need to be able to realize first is that there's a working set. If we think about the previous example, most people really wanted to look at the latest version, and they didn't really care about the previous 10 versions. So what we want to be able to do is get very rapid access to the latest versions for people to access, and the older versions we can manage in a slower, less rapid way. And we look at the core technology to enable that. The first thing is called deduplication. So when we think about what I talked about before, going from version 1 to version 2, and if I only change one word on the cover sheet, maybe that's a change of 10 bytes. But if I continue the way I was, that'll be another 5 megabytes. So what deduplication does is really break up these PowerPoint presentations, or anything really, into a series of blocks. And if it finds the same block, it never stores it a second or a third or a fourth or a fifth time. It just has a reference count that we've got it using it more than once. So the big net effect of that is if I go from version 1 and I change one word on the title, I just store an extra 10 bytes, not an extra 5 megabytes, which has a massive impact on the amount of storage that I'm going to take up. And we've seen people reducing that by a factor of 8 to 10. Then the critical thing is we're now looking at the world as a series of blocks. And the block rank algorithm, just like the page rank algorithm, knows what blocks people want to get access to, what ones they don't care about so much, and then very old ones that can migrate to a much slower medium. And the core thing then is we want to be able to use block rank and have transparent tiering. So the blocks we want to get really fast access to, we want to put on SSD. The ones that are less important we put on spinning media, and then the third set can go out to the cloud. So really this is the way we look at block rank and transparent tiering, is we've got a working set with very fast tier 1 SSD drives for that high block rank set of content. Then we have a second tier 2 SAS drive for less important blocks that we don't want to have such rapid access to. Then we have a third rank, which is typically maybe 75% of the content that we can tier out into the cloud, that we know that we really have a much less probability of wanting access to. The core things we do here is in the cloud we encrypt that content through military-grade encryption, and as important, we store the key to decrypt that on-premise, so that even if somebody gets those disks from the cloud, they can't decrypt them. And that's thinking like Google.